Ever pondered over the possibility of creating light from a simple soda bottle? A captivating question, isn't it? Well, today we're going to explore an intriguing scientific experiment that does just that. Now, remember, this isn't a conventional light bulb we're making, but rather a demonstration of a chemical reaction that results in a temporary burst of light. We're going to need a few basic materials for this: a clear plastic soda bottle, some water, household bleach that contains chlorine, and a good source of sunlight. Don't forget your safety goggles and gloves. Safety first, always. It's important to note that this experiment involves the production of chlorine gas, which can be potentially dangerous if not handled properly. So please always exercise caution and follow safety guidelines when conducting any chemical experiment. Stay with us to delve into the fascinating world of chemistry, where we unravel the mystery of light generation through a soda bottle. Ready to dive into this intriguing experiment? Let's start by gearing up. Safety always comes first, especially when dealing with chemical reactions. Put on your safety goggles to protect your eyes. You don't want any splashes reaching your peepers. And don't forget your gloves. They'll keep your hands safe from any possible irritation caused by the bleach. Now, let's get our bottle ready. Grab a clear plastic soda bottle. It's crucial that it's transparent so that sunlight can penetrate through. Strip off the label and make sure there's no sticky residue left. You want it as clean and clear as possible. Rinse it out thoroughly and let it dry. This will be our makeshift light bulb. Next, it's time to mix our ingredients. It's like baking a cake, but instead of a delicious dessert, we're going to create a science spectacle. In a separate container, combine water and household bleach. You don't need a lot of bleach for this. A teaspoon or less will do. Mix it with about a cup of water. The bleach is our secret ingredient here. It contains chlorine, which is the star of this experiment. Once you've got your mixture ready, pour it into the soda bottle. You don't need to fill it to the brim. About a quarter to a third of the way full will work just fine. It's like a potion in a bottle, ready to react under the sun's power. Remember, this process involves the production of chlorine gas and can be potentially dangerous if not conducted properly. Always exercise caution and never forget your safety gear. This isn't just about creating a temporary light show. It's also about understanding and respecting the power of chemistry. Great! Now that we have our safety gear on and our bottle ready, we can begin the actual experiment. Let's see what happens when we expose our bottle to sunlight and observe the magic of science unfold. Now let's position our experiment to catch the sun's rays. We're all set to take our experiment to the next level. We've got our clear plastic soda bottle devoid of any labels or residue and our bleach and water mixture ready. The mixture is crucial here as it contains the star of our show, chlorine. A word of caution though, the proportions of bleach to water can vary, but it's generally recommended to use a small amount of bleach, such as a teaspoon or less, mixed with a cup of water. Remember, safety first. Now, onwards to the next step. We're going to fill our bottle with this mixture. Pour in the bleach and water concoction until the bottle is about a quarter to a third of the way full. You don't want to fill it up too much, as we need space for the chlorine gas to accumulate. With our bottle filled, it's time to find the perfect spot under the sun. We want to position our bottle in such a way that it captures sunlight for maximum exposure. Why, you ask? Well, the sunlight will act as a catalyst, triggering the chemical reaction we're waiting for. So take your bottle outside, or if you're indoors, find a spot where it can bask in direct sunlight. The positioning is key here. You want to ensure that the sunlight is hitting the bottle directly, but not too intensely. Too much heat can speed up the reaction and make it hard to control, and too little sunlight may not trigger the reaction at all. So, find the Goldilocks zone. Not too hot, not too cold, but just right. And there you have it. Our stage is set. With our bottle soaking up the sunlight, we're on the edge of our seats, ready to observe the fascinating chemical reaction. This is where the magic happens, where science meets spectacle, all within the confines of a humble soda bottle. With our bottle soaking up the sunlight, we're ready to observe the fascinating chemical reaction. Now we patiently wait and observe. As we wait, let's delve into the science behind this intriguing scene. When the sunlight hits our bottle, it triggers a fascinating chemical reaction. The bleach, which contains chlorine, begins to decompose under the influence of sunlight. This decomposition produces chlorine gas, a greenish-yellow substance that starts to fill our bottle. But how does this process occur, you may wonder? Well, sunlight contains energy. When this energy interacts with the bleach, it provides the necessary kick to break down the bleach, releasing chlorine gas in the process. This is a prime example of a photochemical reaction, where light serves as the catalyst for a chemical transformation. Now, you might notice a faint bluish-green glow within the bottle. This isn't your everyday light show. It's a manifestation of an atomic phenomenon. As the chlorine gas accumulates in the bottle, the energy from the sunlight excites the electrons in the chlorine atoms. These electrons then jump to a higher energy level, or an excited state, but electrons prefer to be in their ground state, a state of lower energy, so they quickly return to this state, releasing the extra energy they had absorbed. This energy is emitted as light, creating the faint glow we observe. This process, known as fluorescence, is the same mechanism that causes objects to glow under ultraviolet or black light. In our case, the sunlight acts as the black light, and the chlorine gas is the object that fluoresces. It's a mesmerizing spectacle, isn't it? But while the sight is captivating, it's crucial to remember that we're dealing with chlorine gas, which is toxic. So, despite the temptation, don't look directly into the bottle, and certainly do not inhale the gas. Always prioritize your safety when conducting any scientific experiment. Remember, safety first. Don't look directly into the bottle or inhale the gas. But what's happening inside our soda bottle light bulb? You may wonder. Well, let's unravel the mystery. The magic, or rather the science, begins with the sunlight. Sunlight is composed of packets of energy called photons. When these photons strike the chlorine water mixture in the bottle, they excite the electrons in the chlorine atoms. In their normal state, these electrons occupy what we call the ground state. But when they absorb energy from the sunlight, they get excited and jump to a higher energy level, known as the excited state. You can imagine this like jumping on a trampoline. The more energy you have, the higher you bounce. But electrons, unlike us, can't stay excited forever. They prefer to be in their comfortable ground state, so after a while, they fall back down. And when they do, they release the energy they had absorbed. This energy is emitted as a photon, a packet of light. Now, the color of this light depends on the amount of energy the photon carries. In the case of chlorine, the light emitted is a bluish-green hue. This is why, under the right conditions, our soda bottle appears to glow with a faint bluish-green light. It's not magic, it's science. However, it's important to remember that this experiment produces chlorine gas, which is toxic and can be harmful if inhaled or if it comes into contact with your skin. So, while this experiment is a fantastic demonstration of how energy is absorbed and emitted in atoms, it's crucial that it's conducted safely with proper safety gear and under supervision. Indeed, this simple experiment involving nothing more than a soda bottle, sunlight, water, and a bit of household bleach brings to life the principles of quantum mechanics, the behavior of electrons, and the nature of light. It's a small-scale testament to the power and wonder of scientific exploration. As you can see, even a simple soda bottle can reveal the wonders of chemistry. Once the light show is over, it's time to wrap things up safely. This experiment has been a journey from a simple soda bottle to a temporary light emission. But it's important to remember that the gas inside the bottle is chlorine, which is toxic and needs to be handled with care. So, let's do this step by step. First, carefully put the cap back on the bottle. This will contain the chlorine gas and also extinguish the light show. Next, move to a well-ventilated area. Outdoors would be perfect. Here, you can safely release the chlorine gas from the bottle. Make sure you don't inhale it. Afterward, it's time to clean up. Rinse the bottle thoroughly with water to ensure no bleach or chlorine residue is left. It's all about leaving no trace behind, right? And there you have it, a fascinating experiment demonstrating the endless possibilities of science. Remember, safety always comes first. Until next time, keep exploring.